3.5 billion miles from Earth lies one of the most captivating objects in our solar system. It's a tiny, icy world with the strangest atmosphere ever studied. It may have giant geysers, underground oceans. There's even a small chance it has primitive life. It's changing the way we look at Earth and our solar system. This is the former planet known as Pluto. Pluto sits on the edge of our solar system, 3.5 billion miles from Earth. Remote but not forgotten, for generations of school children, Pluto is the 9th planet. But on August 24th, 2006, Pluto lost its planetary status. It was reclassified as a dwarf planet.
Pluto doesn't care what we call it. It doesn't care whether we call it it's going to be the same object whether we call it a planet or a dwarf planet or a minor planet.
Pluto has all of the characteristics of the other planets. In the same way that a chihuahua is a dog, just smaller. Dwarf planets are planets. They're a smaller variety.
Pluto sits on an exciting new frontier of space exploration. A state-of-the-art spacecraft is heading towards it at around 1 million miles a day. Scientists hope that it will shed new light on the formation of the solar system and even the birth of our own planet.
Every time we take a spacecraft and go by a new body, it turns into an entire world that is filled with fascinating phenomena that we would have never understood before.
The fact that Pluto is so far away, it's so small, it's so dim, and may represent now a whole new swath of real estate worth of objects, tells us that Pluto has a lot in store for us to learn about it.
Our story starts with Pluto's discovery. By the early 20th century, 8 planets have been discovered. Many assume that Neptune is the outermost. But astronomer Percival Lowell is convinced there is another planet out there, a massive planet whose gravitational pull is disturbing Neptune's orbit. He calls it Planet X, but it proves elusive, and for good reason. The giant planet theory is wrong.
The original motivations for searching for Pluto were based on bad data, basically. They just didn't have enough information then and good enough data to really solve this problem.
By 1929, astronomers at Lowell's Observatory outside Flagstaff, Arizona, had been searching for Planet X for 14 fruitless years. 23-year-old amateur astronomer Clyde Tombaugh joins the team and is given the painstaking task of comparing vast numbers of star-like objects. Tombaugh captures the images onto large photographic plates using a 12-inch telescope, small by today's standard. He's looking for tiny points of light that have moved across the night sky. Stars remain fixed while planets move. Tombaugh continues the search for over a year. Then, examining the plates taken on the 23rd and the 29th of January 1930, a faint object catches his eye. Flicking between these two images, he sees that the object appears to have moved. He checks and rechecks, making sure it isn't a comet or a blemish on the plate. It seems the young astronomer has discovered the astronomical Holy Grail, Planet X.
He also was extremely lucky to be looking at the right part of the sky at the right time. And of course, he had very keen eyes and skillfully able to pick out that small object as it moved across the sky.
Even though the giant planet theory turned out to be wrong, Tombaugh still found a planet. The new discovery is headline news. The planet is named Pluto, after the Greek god of the underworld. Based on their original miscalculation, they believe Pluto is bigger than Earth. Pluto officially becomes the solar system's 9th planet. Today, over 70 years later, Pluto is still pushing Lowell's modern telescopes and leading astronomers like Mark Buie to the very limit of their abilities.
Even with modern day tools, it's a difficult job to find these objects, and you have to look at a lot of sky, a lot of data, use the computers, use all these tools, and we work down at the very limits of what our data and our telescopes can do.
For decades, even the most basic questions about Pluto remain shrouded in mystery. And the most basic of all, its size. The breakthrough comes in 1978 with the discovery of Pluto's largest moon, Charon. It was a stroke of luck, as no one thought Pluto had any bodies nearby. Astronomers were able to estimate Pluto's mass by looking at its gravitational influence on Charon.
Now we know what the mass of Pluto is, and all of a sudden it goes from this vague, poorly known place to now you know something about it and can start putting it in context.
The results are surprising. Pluto is not larger than Earth. In fact, it's smaller than our own moon. Side by side, Pluto and Charon only cover the width of the United States. But for astronomers, the biggest mystery was why Pluto appeared to be on its own. In 1951, Gerard Kuiper theorized that Pluto was a remnant of a once massive belt of objects circling the outer solar system. This region of space became known as the Kuiper Belt.
Kuiper predicted a huge empty space where we see the Kuiper Belt. He thought that Pluto was a massive body that would have swept out all the objects there. And in fact, that's not the case at all.
Back then, Kuiper didn't know that Pluto was too small to have had this dramatic gravitational effect on other bodies. Maybe there was a belt of icy objects out there, just too small for them to see with their limited telescopes.
By 1985, it did seem kind of odd to me, that, and to other people, I think, that the outer solar system would be a very empty place, where essentially nothing was known except for Pluto.
Mauna Kea, Hawaii. In 1988, Professor David Jewett of the University of Hawaii's Institute for Astronomy begins a dedicated hunt for another object beyond Neptune. Despite harnessing the latest digital technology, the task of looking for a tiny asteroid-sized object at the far reaches of the solar system is a daunting one. A bit like finding a grain of rice on a mountainside, as Jewett demonstrates.
To give you an idea for the scale of the Kuiper Belt relative to the orbits of the planets, I've laid out the solar system using various kinds of fruit and vegetables. So we have a ball to represent the sun. Next to the sun, which is the center of the solar system, we have the rocky planets. So we have to go out to 5 astronomical units, 5 AUs, to find Jupiter, the biggest thing in the solar system except for the sun. Then we go out from Jupiter is Saturn, located at 10 AU. Out from Saturn is Uranus at 20 AU. Uranus is the first of the ice giant planets, and Uranus has a near twin. It's called Neptune. Neptune is over here at 30 AU. And then just beyond Neptune comes the famous Pluto, represented here by a tasty macadamia nut. And Pluto moves in and out from the sun, but it's roughly located at 39 AU. So we'll put that back where we find it. Kuiper Belt starts roughly at the orbit of Neptune and goes out to larger distances. So we can represent that by grains of rice from this bag, which I'll drop on the ground, These are Kuiper belt objects falling in space, and here they go, but in fact they go very far out. They go out in this direction, and in fact it goes out so far that I can't throw it far enough. It goes out to the hill in the distance, far beyond me.
But in 1988, all this is speculation. It's just a theory. There's no hard evidence of other objects in the Kuiper belt. Dave Jewett continues believing there have to be more Kuiper belt objects out there, somewhere. For 4 years, he toils in the thin air of Mauna Kea's high-altitude observatories. He has no idea how big or bright any of the objects might be. Then in late November 1992, he and his colleague Jane Liu spot a faint moving dot in the sky.
It was a very, very definite object, far above the noise, far above the threshold of uncertainty. We're completely sure that we found the first really slow-moving thing in the solar system since Pluto.
And it's small, just 140 miles across. Its diameter is just a tenth of Pluto's.
If we were able to find one body in 0.1% of the sky, which was the case, then we knew there must be something like 1,000 times more objects than we'd found.
Jewett's discovery has astounding implications. Now astronomers know there are potentially thousands of icy bodies, escapees from early planetary formation, orbiting out beyond Neptune. And Pluto is just one of many. Perhaps Pluto is not a planet after all. The discovery of thousands of objects in the Kuiper belt opens up a whole new realm of planetary possibilities. Pluto no longer marks the edge of the solar system. There are hundreds of objects in the Kuiper belt waiting to be identified, and astronomers are scrambling to find the great prize, an object bigger than Pluto. In 1998, Professor Mike Brown at the California Institute of Technology joins the hunt. At the Palomar Observatory in Southern California, Brown's team embark on an extensive search.
We had started this project of scanning the skies 7 years earlier, and with the idea that we wanted to see if there was something bigger than Pluto out there. We thought there just had to be.
Unlike Tombau's manual method, the team uses a computer-controlled telescope with digital cameras to take hundreds of images across the whole sky.
Clyde Tombaugh used photographic plates, and he would take 2 photographic plates and compare them and look for something that moves. We now use the digital cameras instead, and the computer does most of the work that Clyde Tombaugh did.
On October 21st, 2003, the computer records a snapshot of space and gives it a code: 2003 UB313. But with such a backlog of images, 2 years pass before Brown has a chance to review it. Like Tombaugh, it's now down to his skill and judgment to spot one significant object among thousands.
And suddenly this big bright object appears on my screen, and my very first reaction, what did I do wrong? Something must be wrong here. This can't be right. And I checked everything, and realized, no, this is really there. And I immediately picked up my phone and called my wife and said, hey, I just found a planet.
2003 UB313 is around 70 miles wider than Pluto. And though it's 3 times further out than Pluto, it's one of the brightest bodies in the Kuiper belt. Astronomers call it Eris.
We knew immediately, once you start discovering other objects beyond Neptune and look at the distribution of their sizes and the rate at which you're discovering, it was just a matter of time before you would find one larger than Pluto. And in fact, that's happened.
I never actually really thought we were going to find that one bigger than Pluto, so it was sort of a fun moment.
For Brown, Eris is the discovery of a lifetime. For Pluto, the implications are serious. No longer alone, and not even the biggest or brightest body beyond Neptune, can we still call Pluto a planet? One of the first to publicly question Pluto's status was director of New York's Hayden Planetarium, Dr. Neil deGrasse Tyson.
We first opened to the public in the year 2000, not including Pluto among the ranks of the other principal objects in the solar system. And we got raked over the coals by the New York Times had a page one story saying Pluto not a planet, only in New York. Okay, and then I got like hate mail from third graders, ever since.
Tyson leaves Pluto out from the display because it doesn't fit into his two main planetary categories: the inner rocky planets and the outer gas giants.
Pluto's always been a curious object, primarily because we've known so little about it.
Defining a planet is not as simple as it seems. Take Neptune's moon Triton, for example. Although it's 40% bigger than Pluto, Triton is just a moon. After much deliberation, the International Astronomical Union came up with a new definition. Planets now have to meet three basic criteria. They have to have sufficient mass for gravity to contract them into a sphere. They have to orbit the sun and not some other body, or else they would be moons. And lastly, they have to clear the material around their orbit. Unfortunately, Pluto fails to meet one of the criteria. It does not clear the neighborhood around its orbit. On August 24, 2006, Pluto is reclassified as a dwarf planet.
The word planet hasn't been defined since ancient Greece. Back then there were 7 planets: Mercury, Venus, Mars, Jupiter, Saturn, the Sun, and the Moon. And it was never redefined to accommodate our new understanding of the solar system.
Pluto may have lost its planetary status, but it hasn't lost its intrigue. The more scientists learn about Pluto, the stranger its story becomes. Unlike all the other planets, Pluto's surface is covered with exotic ices, such as frozen nitrogen and methane. There are at least 3 moons orbiting Pluto, a planet 2,000 times less massive than Earth. And Pluto's eccentric orbit is more like a comet's. For almost 60 years, it was also impossible to tell whether Pluto had an atmosphere. And when scientists finally get a chance to look, they discover something remarkable. Pluto's atmosphere is unique in the solar system. It's causing the planet to shrink. Pluto, once an isolated planet, the 9th in our solar system. Now stripped of its planetary status, Pluto is just one of thousands of icy bodies in the solar system's furthest reaches. It might not be alone, it might not be a planet anymore, but Pluto is still intriguing. And as scientists unlock the mysteries of Pluto, they're discovering a world full of puzzles and surprises. Astronomers figured out that Pluto was cold and that its surface was encased by ices, but for 58 years, they couldn't tell whether it had an atmosphere. No telescope on Earth was powerful enough to confirm this basic phenomenon on an object 3.5 billion miles away.
Even using the most powerful telescope available to astronomers, the Hubble Space Telescope, which is a fantastic instrument, Pluto just looks like a barely resolved, very pixelated object. We just can't see much detail.
On June 9th, 1988, NASA's Kuiper Airborne Observatory takes to the skies. Astronomers board this specially equipped high-altitude plane on a journey to the Earth's stratosphere. Their mission is to search for evidence of an atmosphere on Pluto by observing a strange celestial phenomenon. The only way to identify an atmosphere on a remote body like Pluto is to observe it during a type of eclipse known as an occultation. When a celestial object, like a moon or a small planet, passes in front of a star, starlight is sharply cut off if there is no atmosphere present. But if the body does have an atmosphere, the starlight behind it gradually dims as the body passes in front. On board the plane, high-powered telescopic instruments record the critical moment.
Wow, okay. I think that thing has an atmosphere, guys. Yep, atmosphere.
Pluto has an atmosphere. It's similar to Earth's, but extremely thin.
Pluto's atmosphere has many of the same chemical constituents as the Earth's atmosphere, but there's very little of it. If we took all of Pluto's atmosphere and we cooled it down even further than its current cold temperature, and it collapsed onto the surface as a frost or snow, we'd have snow up to the kneecaps.
But how does Pluto have an atmosphere under these frozen conditions? The answer turns out to be linked to its eccentric orbit. Most planets take a roughly circular route around the Sun, but Pluto follows an extreme elliptical path. Its orbit carries Pluto as close to 2.9 billion miles from the Sun and as far out as 4.6 billion miles. By contrast, Earth's distance from the Sun varies by just 3 million miles. Pluto receives almost 3 times more sunlight at its closest point to the Sun than at its furthest point. As it moves towards the Sun, Pluto's surface ices turn into gases. The result is a unique atmosphere. It comes and goes. Mark Buey of the Lowell Observatory in Flagstaff, Arizona, explains that Pluto's strange atmosphere is, in effect, turned off and on by the Sun.
This is a little bit like what the atmosphere of Pluto might be like when Pluto is closest to the Sun. And then as the Sun goes away from Pluto, this is what happens. We're going to stick this balloon into this really cold liquid, and the balloon starts to collapse and shrink and get smaller and smaller and smaller as the pressure of the gas inside goes away. And hold it here long enough, and now I have a totally collapsed balloon. Now you'll notice as I pull it back out, it's starting to warm up again. There's actually liquid air inside there. And the gas starts to expand and swell up. And this is kind of what happens with Pluto's atmosphere, we think, over the course of its year. At perihelion, or when it's closest to the Sun, you have this big atmosphere. And then when it gets furthest away from the Sun, the atmosphere shrinks and could maybe even disappear entirely.
No other known body has such a radically fluctuating atmosphere. And the more scientists study it, the stranger it becomes. Fran Bagenal, professor of astrophysical and planetary sciences at the University of Colorado, thinks that Pluto looks like a comet because it has an atmosphere that leaks into space. Pluto's gravity is so weak that its atmosphere stretches hundreds of miles above the surface.
Similarities with the comet are that the weak gravity of Pluto allow the atmospheric gases to escape. And so, as Pluto gets closer to the Sun, you have greater evaporation and more material escapes. Indeed, it looks very much like a comet in that respect.
When a comet travels towards the Sun's heat starts to affect its icy surface. Ices turn into gases and are blasted away, giving the comet its distinctive tail of ionized gas and dust. Although Pluto doesn't release dust like a comet, it does leak up to half a ton of atmospheric gases every second. And this leads scientists to a startling conclusion. Pluto must be shrinking. Each time it heats up, it gets a little smaller. During our solar system's lifetime, as much as 18 miles of Pluto's terrain may have been lost to space.
And so as a result of this, we expect there to be a considerable variation in the surface, hills and valleys that have evolved over the age of the planet.
Hidden for decades, Pluto's strange surface is obscured to even the most powerful telescopes. But there is a special type of device that can bring it into focus. The infrared spectrometer reads the distinctive reflective signature of Pluto's surface. Using this technology, scientists can piece together a remarkable picture of the strange world of Pluto. Spectrometers tell us that Pluto's surface is covered by exotic ices. Temperatures on Pluto drop to a chilling minus 396 degrees Fahrenheit, so that nitrogen, methane, and carbon monoxide exist as frozen solids. The gases we breathe, see through, and move through on Earth make up Pluto's rocks, plains, and hills. Astronomers think that around 30% of Pluto is made up of ices. Beneath the exotic ice-covered surface sits a water-ice mantle. But is Pluto just a frozen world? As scientists investigate this puzzling dwarf planet, an intriguing possibility emerges. Could there be an ocean hidden beneath its surface? Could the existence of ice and liquid water on Pluto provide further evidence that the Kuiper belt was a source of Earth's water? Scientists believe that Pluto-like worlds may have played a fundamental role in bringing water, the vital ingredient for life, to Earth. In the outer solar system where the sun's influence is weak, water ice is abundant. But could Pluto also have liquid water? Professor Bill McKinnon of the Washington University in St. Louis thinks so. He believes that beneath Pluto's frozen surface, there could be an ocean. McKinnon believes that water on Pluto could exist in liquid form due to the presence of ammonia, which acts like antifreeze. If he's right, water could remain liquid at temperatures far lower than those of the Antarctic.
Bodies like Pluto can actually have oceans. Not oceans on the surface like on the Earth, but oceans down below. And I have basically Pluto right here in this glass, and I can add the water and something like ammonia that would be inside Pluto.
Add ammonia to water, and the freezing point plummets to nearly minus 142 degrees Fahrenheit.
And to make it look more oceany, although we have no idea what the color of Pluto's ocean would be, we'll add some food coloring. Now out there in space, you're a long way from the sun, so it's cold. And so the top will freeze, like on a lake or in the Arctic, and you'll actually start freezing from the top down, and you'll make a thicker and thicker layer of ice, and I'll start it off by adding some ice at the top, which will float. And then, because we can't actually go into deep space, we'll put it in the freezer. But I put an earlier version of this a couple of hours ago, and this is sort of what you'd actually get. You'd actually see an icy layer floating on, I can jiggle it a little bit, a liquid layer that actually won't freeze.
After 2 hours in the freezer, the ammonia keeps the water liquid. But turn the temperature down below minus 142 degrees, and even ammonia-rich water freezes. On Pluto, surface temperatures are a mind-numbing minus 390 degrees Fahrenheit. At temperatures this low, every drop of water should freeze. So for water to remain liquid under the surface, there must be another force at play. a force that scientists believe lies deep inside Pluto's inner rocky core. Here there may be radioactive substances which generate heat as they decay. This heat could raise Pluto's subsurface temperatures to the critical level where ammonia-rich water can exist. It's a tantalizing theory, because whether in liquid or frozen form, the presence of water on Pluto and its Kuiper belt neighbors could hold the key to one of our planet's greatest mysteries: the origin of its oceans. One popular theory suggests that comets, which are rich in water ice, may have delivered water to Earth. But Dave Jewett thinks comets may not be the only source of Earth's oceans. Jewett believes Pluto-like bodies in the Kuiper belt may also have played a part. It would take roughly 1 billion average-sized comets to deliver Earth's water, or one single ice ball 600 miles across. No comet this large has ever been discovered. But in the Kuiper belt, there are between 50 to 100,000 ice-rich objects larger than 60 miles in diameter, and dozens at least 600 miles across. At the dawn of the solar system, astronomers estimate that the Kuiper belt was around 100 times more massive than it is today. Sometime in the past 4 billion years, the Kuiper belt has shrunk.
Several tens of Earth masses, even up to 100 Earth masses of stuff, originally was present in the Kuiper belt and then was lost by some process that remains mysterious.
Could this loss coincide with the creation of oceans on Earth? This is Neptune, the 8th planet and the Kuiper belt's closest gas giant. Computer simulations show Neptune's huge gravitational field may have dislodged Kuiper belt objects, sending them spiraling toward the sun. Parts of them may have collided with Earth.
We know there was a period of time when there was just stuff slamming in all over the place. And that had to hit the Earth too. It's possible, entirely possible, that those objects were Kuiper belt objects, which are full of ice and water. Most of the water is hanging out in the outer solar system, and all the rocks are in the inner solar system, but maybe by these stirring events, you can kind of bring these two areas together.
If the theory is correct, objects like Pluto in the Kuiper belt played a part in delivering Earth's water, vital to all life as we know it. Pluto is slowly yielding its secrets, shedding new light on our solar system. But incredibly, almost 80 years after its discovery, we still don't really know what Pluto looks like. Despite powerful modern telescopes, there are no detailed images of Pluto. These, taken in 1994, are the clearest to date. They were captured by Hubble, the space telescope that escapes the distorting interference of Earth's atmosphere. The largest point of light in the center is Pluto. Its largest moon, Charon, is next to it. To construct a global map of Pluto's surface, Mark Buey turns to Hubble's infrared images.
Each one of these images represents one picture taken with the Hubble Space Telescope. You stitch all those pictures together into a uniform map, which then I can manipulate and make it look like a globe.
This composite globe shows a reddish surface with patches of light and dark, evidence that Pluto has a varied landscape. At the solar system's outer limits, beyond the reach of even the most powerful telescope, Pluto remains shrouded in mystery, but not for much longer.
You either need a bigger telescope or you gotta go there. And so, we're going there.
Right now, a sophisticated spacecraft is racing towards Pluto at around 1 million miles a day. It's ETA 2015. January 19th, 2006. The Atlas V rocket blasts off from Cape Canaveral, Florida. On board, the New Horizons spacecraft. It's on a 9-year journey to Pluto and the Kuiper belt. This is a voyage into the unknown. Since NASA's inception in 1958, its missions have provided stunning pictures and vital scientific information about our solar system. Some have even involved robotic landing vehicles to examine and explore these new worlds up close. NASA has sent spacecraft to every major body in the solar system, except Pluto. Pluto is still waiting to be explored. In the first ever image of Pluto taken almost 80 years ago, the planet appears as a tiny pinprick of light, no brighter than a distant star. Even the latest images, captured by the Hubble Space Telescope, show Pluto as just a blurred ball of light.
Pluto is so far away and so small that Hubble's capacity to see detail is greatly limited.
To get a sense of what it's like to try and see Pluto, the best thing to do is to think about if you were to look at a ping pong ball, someone was to carry it 25 miles away.
An important clue to Pluto's appearance comes from data gathered by another mission to the outer solar system. In 1989, NASA's Voyager 2 skimmed past one of Neptune's 13 moons, the mysterious Triton. This flyby provided astronomers with a tantalizing glimpse of what Pluto might look like.
This icy moon, this large icy moon, that's very much a companion to Pluto, similar size, similar part of the solar system, and maybe had a very similar origin.
Astronomers theorize that many billions of years ago, Neptune slung Pluto outwards and dragged Triton towards it, taking it captive as a moon.
Triton is just like Pluto, but it got captured by Neptune billions of years ago. If we were to fly over Pluto, we would see impact craters and volcanic calderas or collapsed craters and maybe even active venting or plumes, because we see these things on Triton.
Triton's strange landscape suggests that Pluto could be a dramatic place. And on Triton, the most dramatic features of all are geysers. Voyager 2 captured these remarkable images, evidence of geysers that last for up to a year and spurt gas and dust up to 5 miles high. If there are similar geysers on Pluto, astronomers predict that they would be driven by the sun. Although the sun is over 3.5 billion miles away, its heat may still have the power to affect the ice beneath Pluto's surface, turning it into gas. Pockets of subsurface gas would build up and eventually burst through Pluto's frozen surface as geysers. Will Grundy demonstrates how even a small increase in temperature produces a large geyser.
Okay, we're going to put liquid nitrogen into this plastic bottle, and it's very cold at 77 degrees above absolute zero. So as soon as it comes into contact with the hot environment here with the sun shining and the warm air, it starts boiling like crazy. And as it boils, it's going up into gas, giving off a huge amount of gas. And as soon as I screw the lid on, the gas has nowhere to go except up the tube in the lid and out through this cooler full of ice to form our simulated geyser. And here it comes. On the surface of Pluto, don't know what the scale of those geysers would be, whether they'd be very small like this one or maybe a kilometer tall.
Such mysteries will be solved on New Horizons' arrival in 2015. The spacecraft's camera has already been tested 6 months into its epic journey, capturing perhaps the greatest volcanic eruption ever witnessed in space. 76 years after Pluto's discovery, and after 17 years of research and development, NASA's New Horizons spacecraft sets out for Pluto. Traveling at around 1 million miles a day, it's on a 9-year, $700 million journey to reach Pluto and reveal its secrets. New Horizons chief scientist is Hal Weaver.
Yeah, where we are right now is mission control for the New Horizons mission to Pluto. This is where we watch all of the activities that are occurring on the New Horizons mission. We have over here to the left a depiction, a software prediction of exactly where the spacecraft is, where it's pointed. You know, we're following it on its path to Pluto.
In early 2007, New Horizons passes Jupiter, using the planet's intense gravity to boost it toward Pluto. It took the opportunity to test its camera on Jupiter's largest satellite, Io. The results were spectacular. This footage, captured by New Horizons' long-range reconnaissance imager, shows the actual eruption of a volcano on Io's surface.
We were just lucky and happened to catch it when one of the major volcanoes was active. It had spectacular plumes, debris, volcanic debris was flying up for a couple of 100 miles above the surface.
It's a stunning but short-lived encounter. New Horizons soon leaves Jupiter behind. Traveling at over 8.5 miles a second, it's the fastest spacecraft ever launched. It's going so fast that after its 9-year journey, New Horizons will only have a day and a half to see Pluto close up before disappearing deeper into the Kuiper belt.
And that's great for getting there early. But on the other hand, of course, that means that everything is really sped up as we fly by, because unfortunately, we can't just go to Pluto, put on the brakes and stop and hang around for a while. Roughly 3 months out, we're going to have resolution that's better than Hubble, and then it just gets better and better and better as we get closer and closer. But for those last 24 hours where we have this really high spatial resolution where we can see football field-sized features on the surface of Pluto, that all happens very quickly. We're just going to fly by and then just by Pluto and on deeper into the Kuiper belt.
With such a short window to capture data, the team must test and retest the instruments throughout New Horizons' 9-year journey.
Every year, for about 2 months, we're going to wake the spacecraft up and do some testing. Some observations of celestial objects and some commissioning testing of all the instruments to check them out, to make sure they're still performing and they'll be ready to go when we finally get to Pluto in July of 2015.
Ready to answer some of science's most fundamental questions.
The delivery of organic material and water from the outer solar system to the inner solar system may have played a pivotal role in the formation of life on the Earth.
It's just one of many questions about the solar system and its formation that scientists hope New Horizons will help answer. But above all, when New Horizons arrives, astronomers are expecting the unexpected.
I think the most exciting things that we're going to learn from New Horizons are all those things that it never even occurred to us to ask. And suddenly you go there and you realize, wow, we didn't know anything.
One thing is certain. The arrival of New Horizons will be the astronomical event of the 21st century.
It's a whole new kind of world. It's a planet I think everyone has tried to imagine. It's a frontier world. It's going to be the cover of the Rolling Stone.
And perhaps most fittingly, the spacecraft carries the ashes of the man who started the journey to Pluto almost 80 years ago, Clyde Tombaugh. This is a journey to one of the solar system's most puzzling, most mystifying worlds. Once the 9th planet, now a dwarf planet, an isolated oddity that became one of many. A frozen wasteland that could be home to giant geysers and underground oceans, and even possibly to primitive life. With so many twists to Pluto's story, who knows what surprises lie waiting to be discovered? Waiting for New Horizons' arrival in July 2015.